Cool. I won't keep you too long because I do have just a short list for what I'm talking about today. Um, as we know, the data came out. We're third warmest, fourth warmest in North America. I guess what everyone would want to know, the viewers, the main question is, if you can answer this, is kind of broad, is would you say climate change has a play on these changes that are taking place?
Absolutely. So climate change is playing a role in the continued trend of every year being one of the warmest. So it's if it was just one year in isolation from any other year, then we could say, yeah, that's just a, maybe natural variability or something like that. But the fact that, over the last 10 years, 7 out of the last 10 years are among the 10 warmest that we've experienced. And this is happening everywhere on the globe. We're fairly certain that this is, or highly confident that this is due to climate change.
Okay, cool. And it seems sort of obvious, right, that we see these changes, but I guess the real question is if climate change weren't a variable, if we were not causing issues to the planet Earth, would we see any similar changes? Would we be seeing the Earth warm? Would we see similar traits, but it's just changing more exponentially? Or are we able to even speak to that?
Yeah, so if it wasn't for anthropogenic emission of carbon, we would, we could see years in which, is much warmer or colder, but and then even possibly trends. But when we look back at like, for instance, paleoclimate data, so we look at changes over, decades, centuries, or millennia, then we would see that the temperatures could change naturally, but it would be on a much slower scale. So on a human time scale, so we live, 60 to 80 years, we wouldn't even notice it. But if you were to look back over, 1,000-year period, you would see a temperature change. And we do see that that's happened in the past for natural reasons. What makes this so different is that we're releasing so much greenhouse gases in the atmosphere, and the temperature is changing on a much quicker period, so on the order of 10 years. And so that's causing the trend that we're seeing now. And this is, and it's just that difference in time scale or difference in how fast this is happening that distinguishes it from being a natural process.
Okay, and so that makes so much sense. And just to make sure I reiterate this correctly, the change may have happened over a slow time, and in the past you wouldn't even notice the change. But since we've added all the fossil fuels and all that, it's now changing exponentially.
Yeah, I wouldn't say exponentially. I would just say it is changing and it's changing fast.
Got it. Perfect. And of course, the main thing everyone wants to know is any of this reversible?
That's a good question. And right now, it's not reversible on any of our lifetime scales. So right now, even if we were to stop emitting greenhouse gases right now and it were to go back to normal, there's so much heat that's being stored in the oceans and in the atmosphere. It'll take uh, at least a century, if not more, for the temperatures to go down to what they were in the early 1900s or late 1800s. So, it is reversible, but not on time scales that we would notice. However, with that said, when we do stop releasing greenhouse gases, we can kind of limit how warm it gets. And so that's what we're trying to do right now, is to try to limit the warming to something that's manageable. Because by the end of the century, the amount of warming that we expect may not be manageable for us.
So well put. I'm going to use this, by the way. Wanting to know too if if you've noticed from maybe from the data that was just released or just being a meteorologist or being in the field, you might notice that there's differences because this was a global report that came out. Of course, we could look into each area, but are there some areas you're finding that the issues are more rapid, that we're having more issues in different parts of the world?
Absolutely. One of the biggest places where the warming is most apparent is in the Arctic and in, regions north of the polar circle, but then also getting into like some of the places that are near the Arctic, like what we call the subarctic. And so that includes places like Alaska, Canada. British Columbia, and things like that. And those were actually seeing very rapid changes. And then here in the Pacific Northwest, we're not too far from that. And so we're also starting to see some more rapid changes in other places, although maybe it's not as stark as what it is as we go further north. And some of those changes that are becoming a lot more apparent are obviously wildfires and then extreme heat events that are happening well above where we ever see. So a couple of years ago, for instance, in British Columbia, at Lytton, British Columbia. So during the heat dome event, they set the Canada's all-time temperature record at 123 degrees Fahrenheit, and that's near a temperature that is the all-time high in Las Vegas. And then, sadly, a couple days later, the town burned down. And and so British Columbia has been struggling in Alaska too, and a lot of other places here in Oregon and Washington. We're struggling a lot more with the fact that these increasing temperatures are making our forests a lot drier and a lot more flammable, and so we're getting a lot more wildfires because of that. And so that's just one example that's kind of in our backyard of places that are changing a lot faster than other parts of the globe.
That's really interesting to hear. British Columbia would be one of them. And it makes sense, the extreme cold, Alaska near the Arctic, because obviously it's supposed to stay cold, so warming is affecting that. But to have it creep into British Columbia, which is just north of us, it makes me think that kind of like cold air sinks into our area, that it's actually going to be the opposite, where maybe it's slowly growing into, and we're going to have issues in the Pacific Northwest. Um, am I right that the warming is starting to sink down, or are we worried about that?
It not only will it keep doing that, but it has done that. So temperatures here are increasing with the global average. So, the years here in Oregon are about 3 degrees Fahrenheit warmer than they used to be in the, early to mid 20th century. And, that's happening in Washington and places like that as well. It's not quite as rapid of warming as they've gotten in the Arctic. So if you go out to the Arctic Circle and the sea ice out there, the warming there has actually been much higher to a greater degree than we've had. So yeah, we have seen that, and we will continue to see that.
Just to clarify, is it actually the degree is warmer as you go towards the Arctic, or is it just that the impact is greater because, it's this, is it just that it's warming what should be frozen, but it's the same difference and that's just more impactful, or is it actually warming up more north
It
in
is warming up more. Yeah, it
okay.
is warming up more, and the it depends what you mean by impacts. If
Mhm.
you mean impacts to humans or something, or if it's impacts to the environment. And since there aren't many humans up there, it's more impacts to the environment. And the biggest ones that we're, tracking the most is the loss of sea ice, and then the loss of permafrost in the on land around there.
Mm.
And the
Okay.
loss, yeah, so the loss of sea ice is really impactful because it's what we call a positive feedback effect. And what it means is that it's something that when you melt the ice, it stops that reflection of sunlight, and the oceans will absorb that sunlight faster. And so it accelerates that warming over time. And so that's one big feedback effect. The second one is that the loss of permafrost. So permafrost is basically in the soil. It's a state, it's mixed with water and things like that. And so it's kind of like, a frozen combination of soil and water. And within that, there's actually a lot of methane in there. And so when you start to melt this permafrost, you actually release methane in the atmosphere. And some estimates, it varies, but basically methane is a very potent greenhouse gas in itself. And so when you warm it and melt the permafrost, it releases a methane, which reinforces that warming, which can melt more as well. And so those are two big things that we are monitoring very closely and are worried about, because what it essentially says is maybe right now is that the warming hasn't caused that much of an impact, but maybe in 10 years, that impact will be so much more because the warming will have gotten more intense, and these feedbacks will kind of keep playing on itself here. And so that's what we're really afraid about. We're really concerned about, I should say.
Yeah, that makes sense. It sounds like if we can't slow down the damage, then they're probably trying to work on ways to slow down the methane release or control that. Like it's all these little variables that they're trying to attack to make it so that our Earth is around.
Yes.
Um, so I'm glad you brought up the polar ice because in the report there's a whole section on the ice or extent, the ice extent. There's the minimum and the maximum, and I sort of understand that just because, I went to meteorology school, but can you try to describe what the min and the max would be and what that is for viewers who don't know anything about that and they're looking at this data? What does that mean?
Yeah. So you're talking about the spatial extent, like the sea ice edge where it's at, like
I
the
think so because
or is it the
in
minimum or maximum area? Uh,
yes, and that's the it, and I thought it was the area, but then originally I personally didn't even know that there was two numbers.
yeah.
And so if you could describe like what we're looking at with those, the min and the max, and I also want to know, is that reversible? Because it sounds like it's not, but you
Yeah.
tell me.
Um, yeah. So every year, basically, it's pretty intuitive. So the maximum sea ice extent happens when it's coldest. So that's during the winter or early spring. And so basically, when you have a cold winter, the surface of the ocean keeps freezing. And so, the ice will get thicker and it'll go further south. And so that's the maximum sea ice extent. And so it'll be early spring in which it hits its maximum and the reason it's early spring is because that's when it starts warming again towards summer. And so basically when it gets warmer, it'll melt the sea ice. And so in late summer, early fall is when we get the minimum extent there. So basically, expands and shrinks with the seasons.
I see. Okay, so you guys are using this measurement of how big it got during its coldest season and how small it got during its warmest season, and you're using that to really track the climate. That's part of our climate tracking.
That is, yeah, and we have satellites that do that, do a very good job, and then among other types of measurements. The reason that the minimum becomes really important during the summer is that in the Arctic, we're getting now that there's so little sea ice left in the Arctic during the summer that we're actually able to pass ships through there. And so that's and there's, north of Canada into the Arctic, there's what's called the Northwest Passage.
Mhm.
And it used to be you could not, in the wintertime and even into the summertime, you could not pass ships through there. And now you're able to during the summer. And so that opens up a lot of not only possibilities for shipping or things like that, but also it has, these geopolitical ramifications or military ramifications because now, you know, somebody from the other side could get to you quicker at a place that you didn't think they would be able to, things like that.
Wow, I hadn't thought of it around in that regard. And I usually am thinking, okay, it's melting. I didn't think of the political part of it. I also was curious too, because we're finding that some things like if we stop emitting gases, we could go back to maybe our climate being more regulated. But is there anything we could do to go back to regular polar ice caps, the larger size? Are we ever going to be able to go there? Is it even possible?
It is. It's just going to take a long time. So not within our lifetime, but the first step would be to kind of, you know, um, moderate our greenhouse gas emissions. And obviously, we want to be able to kind of, get most of the warming out of that. There are these natural cycles that operate on thousands to tens of thousands of years time scale, and that are completely natural, and which give us ice ages or melted polar ice caps. So historic, or in when we think about like long time periods in Earth's history, we've had many such cycles of either very large polar ice caps or no polar ice caps at all. And so it definitely is possible for us to go back to it. It's just that within our timescales of human civilization, um, we would want to kind of keep what we have here in store because that's what we're adapted to.
And just for those who don't understand it, how do the polar ice caps and how do they relate to climate overall? The ocean, the temperatures, the currents. Can you explain why we even care about polar ice caps way far away when we're here? Just for those who don't get that.
Yeah, so the polar ice caps are a really important regulator for our climate. So they're responsible for moderating our temperature and keeping, so even if we don't live near or within the Arctic or anything like that, they keep the Earth's temperature at a level in which we can survive. And the biggest the most important thing is that it not change it not change quickly. If it changes really quickly, then our weather changes, and then that affects, where our precipitation distributions, it affects our temperature. And so we have almost 8 billion people that live here on Earth, and we're all kind of, in our places and everything. And we're adapted now to where we can grow crops, where we can, get our drinking water to certain temperatures and things like that. And it's very hard for us to adapt quickly to, big changes to our climates. So if want to change where your drinking water supply is, or your food supply is, or things like that, it's a major change, and it will cause major upheaval. And so keeping the climate kind of how it is, how we've adapted to it, is a really big priority. And that's why you should care about, things like the polar ice caps, or, ocean currents, or all these other things that are really fundamental processes which keep our weather and things the way they are, the way that we want them to be.
Would you say that the lack of or the diminishing polar ice caps might be the reason that we're 3 degrees warmer? It all relates, right? That's the reason we're 3 degrees warmer than we were last century.
Yeah, it's part of the reason. I mean, the principal reason is greenhouse gases, and then losing the polar ice caps you know, is due to the greenhouse gases. But the fact that we're losing those polar ice caps will add some additional warming onto this already.
I see. Yeah, it's a combo. Why don't they
Yeah.
just put a bunch of mirrors out there so they reflect the sun?
So there are, it might sound like a crazy idea, but there are a lot of people who are thinking carefully about what's called geoengineering solutions. And so it's essentially trying to mimic what the Earth was doing naturally, but trying to do it ourselves. And so, yeah, putting mirrors or more reflective things in polar regions have been thought about. Maybe the least crazy idea is to actually inject reflective particles high up in the air. And these would kind of act as a way of reflecting a little bit of sunlight and doing that. And so that's called, uh, so those particles are called aerosols. And it's thought that, um, oh, so volcanoes emit them naturally. So when you get a volcanic eruption, they end up into the stratosphere. So we recently, the Hunga Tunga eruption in January 2021, erupted put a bunch of these aerosols up, and there was actually a little bit of detectable cooling on the planet in the year afterwards. And but the thing with these aerosols is that once you put them up there, they start to slowly come out. And so you would have to do this in perpetuity to do it. And some people have thought about doing it temporarily while we figure out how to, you regulate our greenhouse gas emissions. But it's not yeah, it's a you, there are a lot of there's a lot of controversy around whether we should do that or not. But yeah, so that isn't a far-fetched idea.
Yeah, we're probably going to have to use the far-fetched ideas, but the problem is maybe making them is causing other issues to the environment or something like that. There's always this catch-22. So I get
Yeah.
it. But I'm hoping everyone else will get it too after hearing from you. So I think that's all the main questions I have. The only other thing that I had on my list to ask you was there anything else from the data that you found interesting or surprising or that you think would be interesting to the layman that doesn't understand any of this? I don't even know if you had a chance to look at the data yet. It just came out, but would
Yeah.
love to hear what your perspective is on outside of my questions.
Yeah, the only thing I would say, and maybe so this year was what we call the La Nina year. And so during La Nina years, the uh, ocean around the equator in the Pacific is colder than normal. And usually during those years, it actually is supposed to cool the atmosphere. And so, and then there's the opposite to La Nina, which is El Nino, and that's the warming of the ocean, and it tends to warm the atmosphere. So we tend to get warmer temperatures on average during El Nino years and cooler during La Nina years. What was striking about this year is it was a La Nina year. It's a weak La Nina, but it was a La Nina nonetheless. And we had, the third warmest year on record during a La Nina year. So what we're really concerned about is that when we switch to another El Nino year, which we will, if it's not next year, it'll be in a few years, that year will be even much more warmer than it was this year. And so, and the concern is that we have a lot of adverse impacts from this year, from the warming that we've just observed. So when we start to crank that thermostat even higher, we're really worried about that or concerned that these impacts will just keep increasing. Some of those concerns are that we're not adapting fast enough. Forget mitigation. We're just not even adapting our own human system fast enough to deal with this. And now, Earth's going to keep, I guess Mother Nature, if you want to call it that, is going to keep holding our feet to the fire until we listen.
Literally.
Yeah.
And from what I remember, I think the warmest year was that last year, and then 2023 was. I won't hold you to this, by the way.
Oh, yeah.
Yeah, but I do remember it being the last few years were maybe second and first.
Yes, that's right.
Those were La Nina years, or were those El Nino years?
Last
La
year was,
Nina.
well, the year before, 2024 is an El Nino year, and then 2023 was a La Nina year. So last year was the warmest. And so, yeah,
Not a good sign.
not a good sign.
Not a good sign. Yeah, I think that's it. And if you ever see anything in your data, or you think you know of a story that viewers would like, or you think people should know about, please email me. We can meet. I can make it quicker than this. We'll make sure my camera works. But I would love to keep doing this and let people know the truth of what's going on out there.
Sounds great. Yeah. Yeah.
Okay.
You do that.
Thanks, Larry. Thanks so much. And thanks for doing this so last minute. So
Yeah.
grateful to
No
you.
worries. Yeah.
All
Nice
right.
to meet you, Sarah.
All right. Take care. Have a great weekend.
Yeah, you too.
Thank
Bye.
you. Bye-bye.